All right, hey everyone, my name is Dan Topchin. I'm an application engineer here at Markforged. I just want to find out if someone can please send in a response if you can hear me okay, if I'm coming through loud and clear. That'd be great. Joining me today is Ethan Steele. Ethan is with our sales and business development team. He's going to be monitoring any questions that you have. While I'm going through the Eiger presentation to show you how this great software works and how easy it is to use, feel free to fire out any questions that you have to Ethan. If it pertains to the particular part that I'm working on, we'll be more than glad to answer that question at that time. However, we do ask that any unrelated questions be saved to the end of the presentation, where we'll do our best to answer all of those questions. Okay, so let's begin. Again, I'm Dan Topchin. I'm an application engineer. I've been with Markforged for over a year now, and I do have to say that this Eiger software is the lifeblood, and it is what allows all of the great parts, the ability to create very strong, very functional parts on the Mark II printer. Okay, we're going to look at a bunch of parts. Before we do so, though, I am going to show you some resources that are at your disposal when you do have Eiger. At the end of the presentation, we will also talk about how you can pursue a trial version, a 7-day trial version of this Eiger software, and give it a go-around yourself by bringing in STL files and adding some fiber, and you'll learn very quickly, not only after seeing this presentation, but on your own, just how easy this software is to use. Okay. One thing, like, this is the parts library. This is where you can have project. I have 2 projects right now, as indicated over in my left column. I have an orthotic project, and I have a samples folder or project. In here are the sample files that come with Eiger. And this one is an orthotic file that I'll refer to when I talk about the pause feature. But what I'm going to do before I import some STLs, STL is the only file format you can import into Eiger. And again, Eiger works on Chrome and only Chrome, so you will have to download and install that if you don't have it already. Some of the valuable resources at your disposal, if we come to the settings and go to our support page, this will take us to a wealth of resources that we highly recommend you look at and review. Okay, we have information on getting started, troubleshooting, the design guide, how to finish parts, printer maintenance, advanced tips. There's also a great frequently asked questions section that'll allow you to get many answers to many common questions. Down the left-hand side, there's a bunch of other articles. It may look like there's a lot of articles here, and there are, but they're all very short and to the point. Okay, so to read through all of these, it'll probably take you no longer than an hour and a half. And as such, we highly recommend you go through these a couple of times so that you get the gist of what the printer and what the software is all about. For example, I'm just going to show you the design guide right here. And the design guide is what explains basically what sandwich panels are. Sandwich panels are what Eiger will try to create by default. If we take a look at this particular I-beam, for example, we have the flange on the top and on the bottom, and we have the web in the middle. And the highest bending stresses on an I-beam, for example, are on both the top and on the bottom. So if we add rigidity in both the top and bottom flanges, we can create a strong functional part. And by having the web as an infill, which we have total control over, we can create very strong and functional parts. So by default, Eiger will try to create conventional sandwich panels, and you'll see that on some upcoming parts. But if we go through this particular article where we show this particular quadcopter body, this is what is generated automatically. The yellow represents the Kevlar composite material that has been added to this quadcopter body. And it did it automatically. It puts layers of fiber on the bottom and on the top, hence the sandwich panel construction. Okay, this is ideal, and this is what we want. Here's an example of poor fiber layout.
I don't think we're getting through right now. It doesn't look like everyone's got sound.
Okay, we want to hold on one second. I don't think everyone has sound. Hold on a second.
I think I might just start over here. Look at this. I got this start broadcast. Okay, here, and literally from the beginning.
The broadcast is now starting. All attendees are in listen-only mode.
Right through the beginning.
Okay, hello everyone. I think we lost connection there. I apologize. We're going to go through this again. Let me just revert back to the beginning. Again, my name is Dan Topchin. I'm an application engineer at Markforged. Joining me today is Ethan Steele. Ethan is with our sales and business development team. He'll be monitoring any questions that you have. As we go through some of the parts in Eiger, if you have any particular questions relating to those parts as I'm presenting it, feel free to send any questions and we'll do the best to answer them right then and there. If it's an unrelated question, we kindly ask that you hold off and you ask that question at the end where we'll have a Q&A session, okay? Again, I'm an application engineer. I've been with Markforged for over a year now, and it's an exciting product, as you all know, and the software is the lifeblood of what makes it possible to create very strong and functional parts, okay? Here we are in Eiger right now. Eiger is very simple software to use, as you'll see, and at the end of this presentation, which we'll talk about, is how you can get a 7-day trial of Eiger, all right? And that's something that we highly recommend that you take advantage of. As you'll learn on your own, it's very simple to use, but after seeing some of the parts that I go through, you'll be very comfortable moving forward your own STLs. Eiger runs on Chrome, so if you don't have Chrome, you will need to download and install it. You can only import STL files, which I'll do in just a moment, but I do want to show you some other areas before we move right into Eiger. This is the parts library. I have 2 projects right now. I have an orthotic project, which has a sole model in there, which I will talk about when it comes to adding a pause feature to the models, and I also have a samples folder, and these are the sample parts that come with Eiger. These are parts that you can add fiber to, you can print them if you have a printer, but we highly recommend practicing with these particular parts, okay? Before I get into importing any STLs, I want to just show you the resources. If you come up to the settings and click on support, it'll take you to our Markforged support page, and there's a wealth of information here that you should really review. We have information on getting started, troubleshooting information, the design guide, finishing parts, printer maintenance, advanced tips, and of course we have a frequently asked questions section which you should really go through. It's a quick read. Down the left-hand column we have a bunch of other articles. It looks like there are a lot of articles, and there are, but they're very short articles, and it should take you no longer than an hour and a half to read through them all. And we recommend going through them as many times as you can so that the information can sink in. One thing I would like to show you is the actual design guide to show you just how easy it is to create sandwich panels. What Eiger will do automatically is it will try to create sandwich panels on your parts when and where it can. Okay, there are some geometries where it won't, and we'll show you some of those in some upcoming parts. Okay, but what is a sandwich panel? We're all very familiar with I-beams. And these I-beams have both a flange on the top and on the bottom, and it has a web in the middle. Each of these flanges, this is where the highest bending stresses are. So as such, if you create very rigid structures on both of these flanges, you can create very strong parts. The web or the infill in the middle, you have total control over within Eiger, and we'll show you that in just a few moments with some parts. But this is the whole purpose and the whole philosophy behind creating sandwich panels. If we scroll down, we can see a quadcopter body here, which shows automatic sandwich panel construction. When this part was brought into Eiger, automatically layers of Kevlar, as represented by the yellow, and layers of Kevlar were added to the top, so hence the sandwich panel construction. If we scroll down here, this is an example of poor fiber layout, where we have fiber just in the middle of the part, and of course that's not a sandwich panel construction, and as such this is not considered a best practice. So let's move forward, go into Eiger, and bring in some parts and just show you how easy it is. Okay, you can import STLs right into Eiger. I'm going to import a few parts today just to show you how simple it is to use and how simple it is to add fiber where you want it. These aren't going to be real complex geometries. The first thing I have to tell you is that my particular CAD program exports in inches, so I have to change the settings to imperial, so we get the true size. And here we have just a simple block. Up on the left we have our extents, so it's 50.79 by 50.79 by 12.69 centimeters. Okay, let's take a look at the right column where we have all of our part settings. Here we can change the name of it, and what I'm going to do is I'm going to change the name of this box to sandwich, because I'm going to create a sandwich panel construction using Kevlar. I'm going to create different variations of this. The printer version is the Mark II. Anyone that's joining in that may have a Mark I, I'm not sure if you realize this, maybe you do, but if you click on this printer version, you can actually select. By default, if you have a Mark I printer, the Mark I will show up, but you can actually select the Mark II and slice your parts and add fiber and take advantage of the features of the Mark II. You obviously won't be able to print those on your Mark I, but it'll give you an idea about the advancements with Eiger pertaining to the new Mark II printer. This is where you can change the scale. Here you can rotate it on the X, Y, and Z axis, and of course we can use fiber. I'm going to turn fiber on. For most of these parts I'm going to use Kevlar because it best represents on the screen, especially for these demonstration purposes. I'm going to start with concentric fiber, but within here I can choose different, going back to the material types, I could have chose fiberglass, carbon fiber, and of course our high strength, high temperature fiberglass. But again, I'm going to just stick with Kevlar for these demonstration models. The fiber fill type, you can select concentric or isotropic fiber. We will use isotropic. Isotropic can be isotropic alone. And isotropic is great because it has uniform material properties in all directions. And we'll get into that in just a bit with one of our parts, actually with this box model or a variation of it. But for this first one, I'm going to use concentric. And the fiber layers here, the 6 represents that Eiger will create or try to create 3 layers of concentric fiber on the bottom and 3 layers of concentric fiber on the top, hence the sandwich panel construction, and that'll give us 6 overall layers. The concentric fiber rings is set to 2. I'm going to bump this up to 10. You can use whatever you want, but we're just going to start with 10. And we're going to move down and set some of our other settings. Using supports is on by default. For this particular model, since there are no overhangs, supports will not be generated, okay? If there were supports generated, this field will allow us to adjust the support angles, and this can be very handy. By default, it's on 0, but if you had a part that had a very long overhang, using 0 may not be a good idea because you have very long runs of those supports, and by changing it to either 90 or at 45 you can reduce the span of those supports, and it can at times prevent those supports from coming free on the build bed. Okay, we're not going to talk much about this, but I just wanted to point it out and show you that that feature is available. Thin features and use brim, we'll use that in some upcoming parts. Again, my units for the models that I'll be presenting today are imperial, but again, both units, it's either metric or imperial. The layer height shows you the layer height. The layer height for nylon is either 0.1 or 100 microns, or it's 0.125 millimeters or 125 microns. And what the nylon adjusts to is it adjusts to the height of the actual fiber. For Kevlar and fiberglass, the layer height is 0.1 millimeters, 100 microns, so the nylon will adjust to that height. For carbon fiber is 0.125 millimeters or 125 microns in the nylon. So that's just there for reference. The fill patterns that you can choose are triangular. I generally use this by default. It produces it produces the strongest part with this particular fill. You have a choice of hexagonal, which we will show, and of course we'll demonstrate when and why you would use rectangular fill. Okay. The fill density, you have total control of the fill density of the internal fill pattern. We're going to leave it on the default. The roof and floor layers, these are the number of layers that are produced below the fiber layers. What this requires, whenever you put down fiber, it needs a very strong foundation to support the layers of fiber above it, and we will show that just shortly. Number of wall layers, you have total control of the wall layers. You can go from 1 to 4. If you were going to create a solid nylon part, which we will do, you probably want to slide this all the way to 4 so that you have 4 strong outer walls, but you can also come down to as low as 1 wall, and there are benefits to that, which we will show in some upcoming models, but let's just leave it on 2 by default. And of course you have a description field where you can add a description as required. In this case, what I'm going to do is I'm going to save the part. Now when I save the model, what's happening here, not only is the part being saved to the cloud, but this is where all of the slicing of the layers is taking place, and this is where all of the paths, both the nozzle and the fiber paths, are being generated, and we're going to take a look at that now in the internal view. Here in our 3D view, we can rotate the part in 3D space. We have a nice visibility tab up here where by default we actually turn off both the triangular plastic fill and the rectangular plastic fill, and we do this for a very good reason. If we turn on the plastic fill, as you can see here, it just makes the part very busy. So since you have the choice to turn it on, I usually turn it off. How I view models is I'll usually turn it off. I'll turn on my concentric fiber and I'll turn on my walls, and I'll be able to get a good representation of where my fiber is. But let's return back to the default view. Down here is our layer bar, and down here each fiber group is, if I click on it, I can see that I'm selected layers 5 through 7, which is on the bottom, so I can highlight those. If I select the upper group, I'm selecting layers 121 through 123, and if I click in the workspace, it returns back to the 3D view. Okay, now I can add fiber layers in bulk. In 3D view, we recommend using this view for adding layers of fiber in bulk. I will be adding layers in a clone version of this part, which I'll show in just a second, but let's go to 2D view. 2D view is a view of this part looking down at it in the Z-axis. If I click in my workspace, I can actually use the right and left arrow keys and progress through the actual layers. Here we can see our 1, 2, 3 lower layers, the bottom of the sandwich panel, and if we scroll all the way up, I can actually obviously grab the slider and drag it up. And as I mentioned before, the roof and floor layers are below the layers of the fiber. So below this we'll have 4 floor layers, 1, 2, 3, 4. It's actually 1 roof as designated by the outer stitching, followed by 3 floors, 1, 2, 3, and then of course we have our 3 layers of Kevlar on the top. Very simple. Those layers are added automatically. You have total control of that within the part settings. I usually use the floors, the roof and floor settings, and leave it at the default on 4, but you can certainly do whatever you require. I'm going to go back to my part view and go back to my library. Okay, what I'm going to do is, whenever you have your library, if you're the administrator, you have the ability to invite folks to your organization. Anyone that you invite to your organization will be able to see all of your files. They can open them. They can't change any of your parameters or mess with any of these settings, but what they can do is they can clone it. What I'm going to do here is I'm going to clone this particular model again. I'm going to change the name here, and I'm going to do and add isotropic, because what I want to do here is add some isotropic in the middle. So let's go to, I'm going to save it first to save the name, and if I go to my internal view, I'm going to add some bulk layers of fiber in the 3D view right here. Okay, now let's say what I'm trying to do here is I'm trying to print out different variations of this part. More often than not, a sandwich panel construction creates a very strong part, but let's say there's going to be some torque on this part, and let's say we actually printed it and we tested it and there was a little flex in it, and we want to eliminate any torsion or any flex. What we can do is we can add a group of layers of fiber in the middle. I'm just selecting a random amount here, and what it does, it highlights the area in the middle as seen in the 3D view, and what I can do is then go to the actual, I'm sorry, I got this other window in my way. I have to move out of the way. I apologize. So I'm going to go down here again. I'm going to select a selection of layers in the midsection. I'm going to turn fiber on. Concentric was what I had by default, but I want to use isotropic. Anytime you add isotropic to the midsection, this can help reduce or eliminate any torsion or twist that may present itself in a part when it's used in its application. So I'm going to show just how easy that is to do now. Now, with isotropic on, if I leave the value of 10 in the concentric fiber rings there, what it's going to do is it's going to mix, it's going to have a mixture of both isotropic and concentric. What I'm going to do is I'm going to apply those changes and show you exactly what that's doing. So if we rotate that, we saw in real time how it added those layers of fiber. And right now I can see my 10 outer rings, both, that's the concentric, and of course I can have we can see our inner matrix of our isotropic fiber. If I want to go with just isotropic only, which is what I want for this, I can change this from 10 to 0, and of course we can see that it changed to isotropic. If I click in the workspace, we can see that we have the sandwich panels on the top with concentric fiber, and we have our isotropic in the middle based on our group selection in the layer bar. If we go to 2D mode, we can actually take our slider, slide it through. We can see our lower sandwich panel, concentric, slide it all the way through. And at this point, if we wanted to, we could actually turn on the plastic fills so we could see the triangles. Now, as I mentioned before, there's going to be a roof and 3 floors below these layers of fiber. So we have our, let me click on my workspace here, and we have our roof and 3 floors below it, because we need that foundation, a nice sturdy foundation of 100% nylon so that these upper layers of isotropic fiber can sit on that and adhere to it nicely. So here, if we go through these particular layers, if you come and look at the fiber angle up here, it starts at 45. It then goes to 90 on layer 51, then on layer 52 it goes to 135, and what it's going to do, it's going to alternate in those fiber angles throughout this particular fiber group. And what this cross-linking is providing to us is a very strong bond of these layers in its isotropic nature. Okay, very simple. So what I'm going to save this part. I will close this down. I'll go back to 3D view. And I now have a second version of this model. I'll go back to part view. I'll go to my library. And what I can do now is I can create a new project. It's very easy to create a new project. I'm going to call this boxes. I'll save it. And what I can do is simply drag both of these parts into there. Okay. What I want to do now is open this project, and what I can do is I can import a new box in there. And I'm going to go and import a fresh new box. Now, in cases like this, first I have to go down and change it from metric to imperial. I have two versions. I have a sandwich panel box. I have a box with some isotropic in the midsection. And now what I want to do is create a box that has 100% Kevlar in it. Okay, it's very rare when you have to fill parts completely with a fiber of your choice. You tend to do so more so with much smaller parts. But for a part like this, you probably wouldn't have to do it. But I'm going to do it just to show you how easy it is to do in Eiger. Okay, so by coming over here, I'm going to scroll up in the parts settings. I'll give this a new name and I'll call it full Kevlar. I'm not going to change anything with the scale. I'm not going to change anything with the rotation. I will turn on use fiber. What I'm going to do here though is for the fiber layers, if I left it at 6, it's going to try to create 3 concentric rings at the bottom and 3 at the top, but instead of doing that, I want to slide the slider all the way to the right to 120, and what that's telling, what Eiger is going to do here is going to try to fill this part up, all 120 layers, with concentric fiber. Now, instead of 2 concentric rings, I want to have as many rings as humanly possible which go towards the center of the part, and by doing so, what I can do is I can put in a very high value, like an infinity value. So by putting 1,000 in, or even a higher value, will ensure that I'm able to add as many rings as possible to this part, and it will reach as close to the center as it can. It's okay if I have the use supports button on. Again, there's no overhang, so it's not going to create any supports for this part. Thin features and brim, I don't need to use those. We'll use those in an upcoming part. And of course, I'm going to change, instead of having a triangular fill, I'm going to switch to a rectangular fill. And what a rectangular fill is, it is a layer with 100% fill density, but in order to get to 100% fill density, I have to move this slider all the way to the right. So rectangular fill, 100% fill density on all the layers will produce a box, in this case, which is 100% nylon. Let's go and select it here. Now, you always want to refer up to the left. This is a wealth of information up here as well. It gives us our extents. It gives us our approximate print time, which is approximately 15 hours and 40 minutes. However, this print time is an approximation. You will know the exact print time when you send it to the printer, and on the LCD touchscreen, you will actually see the print time on the screen. 99% of the time, the print time is less. In this case, it's probably around 12 hours to print instead of the 15, but it can vary. Here it shows that it's using 4.41 cubic centimeters of plastic, or nylon, and it's using 27.94 or close to 28 cubic centimeters of fiber. Okay. Now let's take a look internally and see what this looks like internally in our 3D view. Actually, I used fiberglass by mistake, which is fine. We can see that this box is completely filled with fiberglass. I'll go back and change the name. That's okay. Actually, let's go back to the part view. I want to change it to Kevlar. It's easy to see, so I'll just save it again. Let it slice, reslice. None of these values are going to change. They're going to stay the same. And we'll go back to our internal view. And here it's just a brighter representation. So this is, as it shows by the layer bar, a box which is completely filled with Kevlar. If we go to our 2D view, we can look at each layer. We can take the slider and slide it through it, or we can use the arrow keys, and we can see that this is as much fiber in a concentric pattern that can be added to this part based on our settings, okay? Now, one of the things that is worth knowing at this point, let's say I wanted to print 3 of these. One of the great features that's in Eiger is it has a pause function, okay? Since we have 28 cubic centimeters of fiber, let's say, for example, I wanted to, I'm going to go back to 2D mode, actually. Let's say I wanted to print 3 of these boxes out, okay? Well, each spool of fiber, whether it be Kevlar, fiberglass, or even carbon fiber, there's only 50 cubic centimeters of fiber on those spools. So if I were to print 3 of these, that would give me, 28 times 8 was at 84 cubic centimeters, and that exceeds 1 spool. So what I have to take into consideration, I have to take that into consideration. I can easily create a pause and anticipate that by taking my slider, and let's say I want to get to, let's say the midsection. Let's go to layer, I don't know, let's say 68. And what that gives me, it gives me 15 cubic centimeters of fiber. So if I create a pause at this particular layer, and I have 3 of them printing, it'll use up only 45 cubic centimeters of, in this case, Kevlar. And what it'll allow me to do is it'll allow me to change the spool. So it's very simple to create a pause. All you do is you come up to here, you create a pause by sliding that on, and it creates the pause. I'm going to save it. And I'm going to show you just how easy it is to print this and add additional parts to it. Okay? I'm going to go to the print. In this case, I'm not connected to any printers. I could easily send this, well, let's first add 2 additional parts to it as we originally planned. I can click the Add Part button. And here's the one part, the box full Kevlar. I'm going to click on it once. I'm going to click on it twice. So I have 3 parts, and they've been auto-placed on the build bed, and there it indeed shows us that we have almost 84 cubic centimeters of Kevlar. We have our pause at layer 68, so we're good to have a pause and add a new spool of fiber. Now, if I wanted to print this, I could easily come and select the printer from my drop-down. I don't have any printers online, but one of the other features, like for example, I have a Mark 1 at home, and my Wi-Fi at home is not great. So what I often do is instead of connecting to it via Wi-Fi, I actually export the builds as MFP files. And an MFP file is a Markforged print file. And this is an actual file that you can load to a USB thumb drive, and you can insert that on the back of the printer and print from that device. I'm going to click on that now. And the great thing about Eiger is it gives you this warning. It says this print uses more than a full spool worth of fiber, which we already knew, but it gives us this warning nonetheless. This print will not complete properly unless you pause it before the spool runs out and replace the spool. Now you can always manually pause it, but it's a best practice to create the pause within Eiger. You may forget about it as it's printing, and you'd certainly hate to see a build go to waste by missing out on an opportunity to change the spools. So here we've already created the pause, and we're good to go. If I print anyways, this will create the MFP file for me, and I can again put that on a USB thumb drive formatted at FAT32, and I can print from that storage device. Okay, but I'm going to cancel this right now. Now I do want to show you another part and show why adding a pause is very advantageous. Okay, let's go back to my library here. But before I do that, I do want to create one more box part. Okay, we've created 3 different variations. We've created a sandwich panel construction. We've just created one with full Kevlar, and then we have one with sandwich panel with isotropic layers in the middle. Now, let's say, for example, you had a part that you wanted to print just nylon, and you can easily do that very simply within Eiger. I'm going to select one more box. I have to come and I got to change my units to imperial. And to change this to 100% nylon, it's very simple. I'm going to come in, I'm going to give it a new name, full nylon. Nothing else is going to change here. I'm not going to turn on fiber because I don't want fiber. Again, it's okay if I have the supports on. Those supports will be generated anyways. And what I'm going to do is I'm going to come down here. And in order to get full, I'm going to select rectangular.
See how to duplicate parts a second time.
What's that?
Who shows how to duplicate parts a second time when you get a chance?
Oh, you mean
Just
like
to clone it.
to clone it? Okay, we'll do that. Absolutely. I'll do that next. So in order to create a full part with 100% nylon, instead of selecting a triangular fill, which would generate triangular fill, or hexagonal fill, which is hexagonal fill, we're going to create a rectangular fill. And this is a layer with 100% nylon, and I'm going to slide that all the way to 100%. I'm going to click Save. And if we go to our internal view, we have here a part which is 100% nylon, okay? If I go to my 2D view, we can see the outer walls and the inner nozzle path of the nylon nozzle, and if we step through it, well, we had to turn on the visibility of the inside there. We can see the alternating paths all the way throughout this part, and this will create a 100% nylon part, okay? Very simple to do. Now, one of the things that I can also do to make this even stronger, as I mentioned before, I can actually slide the wall layers to 4 and have 4 outer walls instead of the default 2. I'm just going to do that now, just so that it ensures that I have a full nylon part with as many outside walls as possible. So if we come back into our internal view and go to 2D view, we can see that we have our 4 outer walls, 1, 2, 3, 4, and then we have our inner nylon, okay? Let's go back to our library. And someone had asked the question how to clone the part. Yeah, it's very simple to do. If you click on it, you have an option to delete it. We don't want to delete it, but if you click this button here, we can clone it. And this is our full nylon one, so if we click on that, it creates a full nylon part, okay? Now, the only problem is the clone doesn't end up in the project, so if we close the project, it ends up outside. We can click on it. We can change the name. We'll just call this duplicate and save it. We come to our library, we can drag that right into our boxes, so now that we have 5 boxes here. Now, if at any time you accidentally delete the project folder, it's not going to delete the whole folder containing all of the parts. Instead, what it's going to do, it'll delete the project, the index, but what it's going to do is it's going to add all those parts externally here, and I'll show you that just now. Show you that right now, just show you what's going to happen. It just basically brings those all out into the parts library, okay? So what I'm going to do is I'm going to move on to some other parts. I'm going to move on to a bracket, okay? We're going to learn a little more about the features of Eiger. I'm going to go through some of these settings a little quicker. I think you're getting the gist of it, just how easy it is. Had to switch to imperial because it is in inches. Here I have a particular part. This part is on the small side. So for this particular part A, I want to fill this with 100%. Again, I'm going to use Kevlar because it represents well on screen for these demonstrations, and I'm going to do that right now. So I'm going to change the name, and I'm going to call it Full Kevlar. You can name it anything you want. I'm just going to name it. I don't need to change the scale. I'm going to turn on Use Fiber. I'm going to use Kevlar. I want to use concentric fiber. What I'm going to do is slide the slider all the way to the right to 36 layers. The concentric rings I'm going to change to 10. I know that based on experience, it's more than enough to fill this. I'm going to go to my advanced settings. Although supports is on, there's no overhang, so I don't have to worry about supports being generated. We'll touch on thin features in just a moment. I'm going to leave all of the other defaults, and I'm going to click the Save button. Now, in the upper left, always refer up here. It shows us our extents. It shows us our approximate build time. It shows that we're using 1.5 cubic centimeters of nylon and almost 1.3 cubic centimeters of fiber. But let's take a look at our part internally. Okay? Here we can see our part, and we can certainly see that we've added fiber to the midsection of this part. Okay? But where we didn't add it is in the most important areas along the outer walls of this part. Okay? Now, using some of the other features in Eiger, we can certainly see if we can add more fiber, but let's take a look at this in 2D mode and find out, get a little more explanation as to what's going on. One of the great features about the Mark II is in its minimum fiber length. The minimum fiber length that needs to be printed is only 40 millimeters, okay? On the Mark I, the minimum fiber length that had to be printed was about 610 millimeters. So the advancements of the Mark II are great, and reducing the minimum fiber length to 40 millimeters allows us to fit fiber into much smaller areas. Now, if we look at our area here, our cross-sectional area, I'm going to turn on this so we can see it a little. Actually, let me turn it off. It's a little too busy. We can see that we're trying to fit fiber in this area here. Now, the cross-sectional area that you need in order to sustain that minimum fiber length of 40 millimeters is approximately 45 square millimeters, okay, which is not a lot, okay? So in this area here, we weren't able to add any fiber, but what can we do here to increase the cross-sectional area? Well, we have 2 walls, and that was set by default. If we remove one of these walls, that'll give us a larger cross-sectional area, and that may allow us to add more fiber. So let's go to our part view, and let's change that setting in our advanced features from 2 down to 1. We will save that. And we can see that it's added a little more fiber. Let's go internally. And we were able to add one more ring of fiber there. Okay, and that's great. One is better than none. If we go to our 2D view and scroll up to layer 20, we can indeed see by going from 2 walls down to 1, we were able to create more cross-sectional area so that we have more fiber, in this case Kevlar, in those outer walls.
We got a good question about looking to find out whether or not the 2D or 3D views, the lines that you see on the screen, do they represent the actual fiber paths, or is it just a representation of the pattern that we're adding to that area?
That's a great question. I'll answer that in just 1 second, okay, but thank you. That's a very good question. Yeah, just to answer it briefly now, the white represents the nylon nozzle path. It'll extrude nylon. The nylon width is 0.4 millimeters. And of course the fiber is represented by the yellow. There are 2 nozzles on the Mark II. There's the nylon nozzle and the fiber nozzle. The yellow represents the nylon nozzle path, and the width of that is 0.9 millimeters. Okay, but we'll take a look at that more closely in just a second. But getting back to this, I have 1 ring of fiber in here. I'd like to try to squeeze in 2. Can I do that? It's a possibility that I can, provided that I'm willing to make a compromise. Okay, if I come down to my advanced settings, one of the settings that we have in here is using thin features. Okay, now thin features, let's open up the help button. Anytime you click on one of these question marks, the help button will come up and it says this will preserve thin features. Select this feature if your part has extremely thin walls you need to preserve at the expense of some dimensional accuracy. Okay, if I turn this on, more often than not, it allows for the addition of more fiber. However, it will alter my dimensional accuracy. For my particular part here, and what its intended application is, I have some clearance here for the actual holes that the bolts will go through. The outer walls will not bump up against anything, so if it's a little larger, I'm okay with it. So I have some wiggle room, and I'm okay with compromising some dimensional accuracy for this particular part. So as such, if I turn on thin features, this may allow me some more fiber. So turning that on, I'm going to click Save. And if we go to our internal view, we can indeed see by turning on thin features, we were able to add another ring of Kevlar around the outside. Okay, now getting back to that question, we can see the 2 rings there. So in this particular case, this is the type of part that I would want to print. Because I have it now completely filled with Kevlar in this case, because it's not going to bump up against anything, it only has 1 outer wall, I'm okay with that. It has a, again, a full fill of Kevlar supporting it behind it. So this is going to be a great part for me to print. It's going to be super strong, and it's going to fit my intended application and meet the strength requirements. Going back to the question about the paths, that's a great question. We'll start on layer 1 here. We have our outer wall. These lines here are the nylon paths. So this will be the nylon nozzle extruding the fiber along these paths. And if we go to layer 2, it's going to alternate, and it will follow those paths. And if we come up to the fiber, we will turn on the visibility so we can see the fill inside. So wherever there's white, it will extrude nylon. Wherever it's yellow, the fiber nozzle will extrude in this case, Kevlar material. Any areas where it cannot put in fiber, it's going to put in actually nylon. So I hope I answered that question okay, and thank you for that question. All right, so we'll go back to our part view. We're going to go back to our library. We're going to bring in another part. We're going to put in another bracket, okay? And in this case, we're going to show how you orient your part is very crucial when it comes to adding fiber. In this case, I'm going to go to Imperial. And here we have this bracket. We obviously want strength in both sides of this bracket. What I want to do is I want to try to fill this up 100% with fiber. And I'm going to come down and turn on fiber. I'm going to use Kevlar again. Again, I like using it for demonstration purposes. I'm going to use concentric fiber. I'm going to take the slider. If I leave 6, it's going to try to create a sandwich panel, but we don't want to do that. We want to try to fill up this part, all 500 layers, with concentric fiber. In this case, I'm going to give it a value of 10 concentric rings. And again, you can change this, you can play around with it and experiment. There is a lot of experimentation, but as you get familiar with it, you'll get a better feel as to which values you need to plug in for certain types of parts. Using supports, I certainly want using supports on because I need supports in that hole, so in this case supports will be generated. I'm going to leave the support angle at 0. We certainly don't want to change the angle of those supports. In this case here, we'll use the brim feature in just a moment to show that feature. And what I'm going to do is I'm going to click Save and see what this generates for us. Okay, if we go to our internal view, we can indeed see that this is filled with fiber. The fiber surrounds this hole very nicely. We can see the support structures. If we want to see just the support structures, we can select that and see that it is indeed there. But instead, what we do here, we have a problem. We don't have enough concentric fiber around this bottom hole. And the reality is, if we look at this, if we zoom in on it, let's just take a look at just the concentric fiber itself. We can see that the length of this fiber is going in the wrong direction. The strength of the fiber is in the direction that it travels, and we don't want the strength in this axis. We want it on the edges of this bracket so it can be very, very strong. So we can easily change that. Let's go change that by going back to our part view and reorienting this part for optimal fiber placement. What I'm going to do is I'm going to put 90. I'm going to lay it down. Okay, and what that's going to allow, it's going to allow concentric to fill up both sides of the bracket, and that's going to allow for the best fiber placement for this particular part. Okay, you can obviously have different variations of fiber, but for demonstration purposes, we're just going to stick with the concentric fiber. But what I am also going to add to this part, because the footprint of this part is a lot smaller than it was when it was sitting flat, we have this footprint of the base. I want to use the brim feature. What the brim feature does nicely is it adds a wider base to the part, and it allows it to, one, maintain its flatness, and two, it will also help from having the part come dislodged from the actual print bed. This print bed, it's not heated. It's a print bed that we use a Elmer's glue stick. It's a disappearing glue, and this part may be okay without a brim, but just for insurance reasons, I want to add the brim to it. And again, it'll create a wider footprint so that it better adheres to the build plate. And this is this feature becomes more useful when it comes to much smaller parts. But we're going to show it here again for demonstration purpose. I'm going to leave all the settings the same. I'm going to click the Save button. And let it finish slicing. And now it's complete. We'll go to our internal view. And here we can see that we have complete, we can see that this has complete fiber layout. The fiber is running in a nice direction. It's surrounding the holes. We have our brim. Let's take a look at this brim in 2D mode. What this brim is, it's 5 layers of nylon. Okay. Now again, what I want to point out here is you always want to look at the part stats in the upper left. This is at this layer here, it's 8 minutes. This overall, it's going to take approximately 15 hours and 49 minutes estimated print time. Again, this print time is an estimation. The actual print time will show up on the LCD screen when you send the build to the printer. Okay. Here, we're going to just take a look at the brim real quick in 2D mode. It's 5 layers of just strictly nylon. The first is the first one, second, third, fourth, fifth. Now, what you need to see is that there's an actual gap around this, and what this gap provides to us is that there will be some bleeding of the nylon, and when it bleeds into it, it almost acts like, creates kind of like a perforation. So when this part is complete and you remove it from the build bed, you can generally pull this right off with your hand, and it pulls right off. So it's a great feature, and you should really take advantage of it, especially when needed. Okay. And if we go through this with the slider, we can see that we indeed have our concentric fiber throughout the part. We can see that it's filling up these islands very nicely. We have our supports supporting the holes. And we can see that it finishes off. Now this down here, a lot of folks ask, what does this representation down here mean? Well, this is a representation of the fiber. Again, this is our layer bar, and this is a representation of the fiber as it's used throughout the part. These lower valleys is where less fiber is used, and it's referencing the layer with the most fiber. Okay, so if we go all the way to layer 5, for example, this layer has the most fiber that was able to be squeezed into this part, and of course if we come to the midsection where we have our holes, we have less fiber. So this is a representation based on the layer with the most fiber. Okay, it's a good reference to look at. Let's go back to our part view, and here we have our part. Now let's say we wanted to print this part again. We can simply go to print, and we can go up and we can add the parts. In this case, we can go up to our selection. We can add any part to our build bed as long as it's the same material type as the part that we have in there currently. Since we have Kevlar, we can add any other Kevlar parts we want. We could add strictly nylon parts to it. The thing we can't do is mix materials. We can't mix carbon fiber parts with nylon or with fiberglass parts. What I want to do is I want to add 2 more parts to this. So I'll click on it 2 more times. I'll close this. And what I can do is I can select these in the workspace and move them around. Now the one thing you have to take into account that this does have a brim around the base, so we want to make sure that those brims don't collide. So we want to give it a little more room. We could probably push them closer if we want, but I'm just showing this how easy it is to move around. Okay, we can then, if we zoom out, which is a nice feature, we can actually see the actual printer and how the parts are oriented. It's very cool. Nice thing to play around with, impress your friends. We can then export this build, or again we can print this directly to the printer if we had a printer online. Very simple. Okay, let's go back to our library. One of the things that I did want to show with adding a pause was this orthotic model, and then I'll move to the final part, which is the manual brake lever. And I want to click on this part, and having the pause feature is great. Here's an orthotic part. We're going to go into the internal view. And there are 2 cavities that have been added to this part. There's a cavity in the heel, which was designed to have a pressure sensor, and there's also a cavity in the midsection for an RFID tag. So in these cavities, you can actually design parts to hold electronic components such as pressure sensors or RFID labels, or you can actually insert hard mounting points like nuts so that you can actually screw other parts that you've printed together and create a much larger assembly. Now in this case, I'm clicking in the workspace so I can use the right arrow key. Here we can see our cavity that's been created, and we want to create a pause at the right time. Okay, and that right time for the heel, we can see that this cavity is opened up, is going to be, I actually have to come to visibility and turn this on, is we want to create a pause right before it closes off. This is the layer closing off that cavity as we're looking down at it from the top in the Z-axis. So what I want to do is I want to create a pause at layer 11. I'm simply going to come and toggle that pause button on. And it will do is it'll pause after this layer. And what it'll also do is it will send you an email notifying you that you can come and remove your part from the bed. You can actually remove the whole build plate. It's on a kinematic coupling, and you can go over to your workbench and you can insert that pressure sensor, return the plate back to the printer. It's accurate within 10 microns repeatability, and then you can resume the print by simply selecting resume on the LCD touchscreen. But before you do that, before we go to that, we want to actually create a second pause so that we can come in and add the RFID label here. So where would we add this next one? Well, on layer 17 is where it starts to close that particular cavity. So we would want to create a pause on layer 16 before that cavity closes over. And again, it would send us a second email notification. We would come to the part, take out the build bed, add the RFID tag, return it back, press resume, and we would be on our way to embedding those parts or overprinting them. Okay. If at any time you do add some fiber and whatnot, you can actually come in and you can revert back to that particular original save setting. So by clicking revert, it erases those pauses. Okay. I do want to go to the library right now and just go back to one part just to show something. Let me close this project. I do want to come back to this bracket, for example. Let's say you wanted to create a variation of this, but you didn't want it to have, all of the fiber that was in there. I'm going to clone it again. Okay, so this is a clone, and I'll just give it version 2. And in this case, when I save it and I go to the internal view, one of the nice features about working with the layer bar is that you can go in and modify your fiber layout whenever you want. I may want to print out a version like this, but maybe I don't want to use that much Kevlar or fiberglass or carbon fiber, whichever fiber it was that I selected. I can easily come in within 3D mode. Like we were able to add bulk layers, I can subtract bulk layers. So let's say I want to remove some of these layers. I can simply come and drag out a bounding box. I'm kind of doing it by eye right now, but you can come and you can get a little more detailed, obviously. And I'm just going to turn the fiber button off, click the apply changes, and it removes fiber from that area. I can easily come to the top section and drag out a selection box and then turn that off as well. Now, the more fiber you have in a part, the longer the print time is going to be. So taking that into consideration, you don't always have to fill a part up with the fiber of your choice. More often than not, it's overkill, but there are going to be times when you need to, but just keeping in the back of your mind that the more fiber, the longer the print time, so use it accordingly. I can then save this, and I can print out both of these brackets. I could print the full one, and then this version in the same build, and I can have both parts to test in my intended application. The last part I want to show is the manual brake lever, okay, and it's right here. This is a great part. One of our mechanical engineers, Nick Sunday, modeled this, and actually you can purchase this part, and I'm going to show you where you can purchase that on the Markforged website. You can get a nylon version and a carbon fiber version. Highly recommend doing it. It's $20. It's great parts. What I'm going to do is I'm going to turn fiber on. In this case, I will use carbon fiber for this part, and I'm going to start with a conventional sandwich panel. And this part's going to show that, well, let's first go through it. Using carbon fiber, have a 6, so it's going to try to create a sandwich panel with 3 layers of carbon fiber on the bottom and 3 on the top, if it can. And I'm going to switch this to 10 concentric rings. And I'm going to leave all of the other default settings, and I'm going to click Save. Okay, let's go to our internal view. Inside the internal view, we can see, as represented by blue, the actual carbon fiber. So right here, we were able to create the bottom part of the sandwich panel, but the top part didn't get created because the top part of this part is this area right here, and there wasn't enough cross-sectional area to support any fiber there. And even if it was, it doesn't create a very strong sandwich panel. So for a part like this, we actually have to manually come in and create those individual layers. And again, we showed how to add bulk layers by dragging out a selection box here. What we want to do is we want to go to 2D mode now and add those individual layers to the top. Okay? What I want to do is I want to come up, I want to turn on my triangular fill, just so I can better see it. Now this is the part where it tops out. Okay, we're going to have 4 layers of nylon. There's the first one, second one, third one, and the fourth one. Below that, I want to have 3 layers of fiber. So I'm going to count down 1, 2, 3. So on layer 90, I'm going to turn fiber on. It's going to remember the default values from before. It's going to add 10, which is perfectly fine. I'm going to go to layer 91. I'm going to turn on fiber. Or I can actually hit the F on the keyboard, which is a hotkey, and it'll add fiber. And then I'm going to go to layer 92. I'll hit F again on the keyboard. And now we've created our sandwich panel construction for this particular part. Let me turn off the triangular fill so we can see it. Okay, so this created a sandwich panel. We had to create the top fiber group manually, which is very easy to do and fun to do. Now what we want to do is we want to fill the midsection. We could easily have filled the whole part up with 10 concentric rings, but that may be overkill in a lot of situations. Our goal is to use less material on certain parts, but optimize and make it as strong as possible. So what we can do is we can actually come to our 3D view. We can drag out a selection box in the middle here. And what I want to do here is I want to turn fiber on. And instead of having 10, I just want to have 3. I don't need to have those layers completely filled with carbon fiber. I just want 3 layers. And what I want to do is hit Apply Changes. And we can see in real time how it's adding those layers in the middle. and we have our part, our carbon fiber, our brake handle reinforced with carbon fiber. Again, up on the left, looking at the stats, we have approximately 3 hour and 55 minute estimated print time. We're using 15.62 cubic centimeters of plastic, 13 1/3 cubic centimeters of fiber, and this would create a strong functional part. And this is the type of part, as it's laid out, that you can purchase, and we'll go there in a second after we answer the questions. Yep. Now, one thing to always remember is that these are nylon parts reinforced with fiber, okay? So let's take a look at this in 2D mode, and we'll take a look at the layers, and just to show you, again, the nylon nozzle path and the fiber nozzle path. For example, here we have these two lines of the nylon nozzle path. We have two walls as set by the default, and again, the blue represents the fiber nozzle path, again, the blue Kevlar, the blue carbon fiber. If we go to 3D mode, again, using the visibility, we can turn this off. We can turn on the concentric fiber and just look at the fiber. And again, if we want to just see the outer walls, again, this is a nylon part reinforced with fiber. We can easily do so. I like to turn on these two, and that gives me a nice representation in view of this part. Okay? And that is the Eiger demonstration. Are there any questions that we can answer? Ethan has been monitoring. Any questions? Anything come in, Ethan?
People are curious. I think you just addressed the outside of the entire part is a nylon, but are curious where else there's going to be plastic if you were to crank the fiber all the way up to 100%.
Yeah.
What's holding the fiber together, and how is it that and how is it possible that it's not a purely fiber part?
Yeah, I mean, all of the parts that are produced on the Mark II, it has an exterior nylon wall. Again, you can go down to one wall, you can go up as high as 4 walls, okay? If you would like it to be one wall and it's not going to collide with any other parts, you can certainly do so. When you add fiber throughout a part, wherever fiber can't be added, nylon will be in its place, but you have total control over that. Let's go back, for example, to, let me first save this, and we'll go take a look at our simple cube, and hopefully that'll answer the question. Okay, so let's go to our, well, let's just import another cube just to start from scratch. Okay, here we have our box model, and we want to add fiber all the way throughout this part, okay? We're going to simply use fiber. Again, I like using the Kevlar. We'll use Kevlar. I'm going to add an infinity value here. Again, we can choose whether it's concentric or isotropic. We're going to stick with concentric now just for consistency, but I'm going to put a very high value in here. And this is going to tell Eiger to try to put as many rings as possible in this particular box, okay? Then what I want to do is simply use the defaults, okay? And I'm going to save this. And this is going to replicate exactly what we did before earlier on, but we'll take a closer look at it.
This is a good question. What is the minimum area for reinforcing with fiber? So what's the smallest area that we can actually add fiber to?
Yeah, the smallest area, you need a cross-section. I do have a part that I can bring in that shows that, and I'll open that part in just a second. And that's going to be a function of how many walls you decide to have, but I will bring in a very small part and hopefully answer that for you. It's roughly about 9 millimeters in diameter if it's circular, and you're going to use concentric. But again, going back to the 45 square millimeters on a rectangular type basis. But I do have a small part that does kind of show that. But let's first address this, and we'll move on to that. Okay, so in this particular part, based on our part settings, we have 2 outer walls, okay, and we have the nylon, okay? So again, these are nylon parts reinforced with fiber. What happens? Oh, my apologies. I don't know why it didn't fill all the way up. Let me go back to it here. I forgot to slide the slider up. I didn't completely fill it. Okay. Let's go to our internal view, go to 2D view, and we'll take a look at it. All right, so we have our 4 layers of nylon on the bottom, okay? We could easily have changed that within Eiger. We can go to the roof and floors, which is set to 4 by default, and we can lower that down to 2 if we so desire. But for this is the outer part of our part, and inside we have our concentric Kevlar. If we turn on our rectangular fill so that we can see that, wherever there isn't fiber, there's going to be nylon. And how this all becomes Kevlar in this case, is that the Kevlar fiber from layer to layer will bond to each other and create a very strong part, okay? I hope I answered that correctly. Is that? Mm-hmm. Hopefully.
We have a question about what is the best way to align a part that includes threads. So what's the best way to align a part on a print bed if you're adding embedded parts?
Yeah, if you're going to do threads, to maintain dimensional accuracy with threads, your best bet is to orient it so that the hole is in the Z-axis. That's not unlike any other 3D printers. So whether or not the fiber will reach into those threads, that's where you can potentially, depending on the size of the part you're bringing in, that's where you may want to use isotropic with some concentric rings.
Is it possible to print with more than one type of fiber in the same part?
No, you can only stick with one type of fiber. You're going to use nylon and Kevlar, for example, or nylon and fiberglass. You can't mix fiber types together.
Do you have any good recommendations or tips or tricks for getting strength in both X and Y and any other tips to add strength to the Z direction?
Yeah, when you want to add strength throughout the part, the best way is to use isotropic. Isotropic, as mentioned earlier, the material properties are uniform in all directions. This is something, if you wanted to create the strongest part, you would use isotropic and you would use carbon fiber, and wherever it could fit it, that would create the strongest part possible, okay? Now I'm going to take a look at this part because they'd asked about the minimum features, so. All right, so here's a part that kind of represents what you can think of when it comes to minimum features. As mentioned before, the minimum length that you can print out of the Mark II is 40 millimeters of fiber, okay? And you need to be able to lay that fiber down, and you need roughly a cross-sectional area of about 45 square millimeters or a diameter of about 9 millimeters, and it's going to vary. As you saw before, you have total control over reducing the number of walls to allow for a greater cross-sectional area, or what you can do is you can actually use the thin features, and the thin features, as we saw in that bracket with the two holes, was able to squeeze in an extra ring of fiber. Now in this case, this is a particular model I show folks, and it can vary from geometry to geometry, but I think this is best representative of the minimum features that folks often ask about. What I'm going to do is I'm going to use fiber. I'm going to use my good friend Kevlar, and what I'm going to do is I'm going to try to fill this up, and I'm going to try to add I'll leave it on 2, but I don't know if it's not going to fit 2, obviously. And I'm going to leave all the default values, and I'm going to click Save. And if we look in the upper left, again, you always refer to this. It gives you the stats of the part. We're using 0.12 cubic centimeters of plastic and 0.01 cubic centimeters of fiber. And we're going to take a look at this in the internal view. And we're going to look at it in 2D mode. In 3D mode, we can certainly see that one ring of fiber. Let's go to 2D mode. And we can slide our slider to that one ring. And as mentioned earlier, the width of the actual nylon wall is 0.4 millimeters, so we have 0.4 millimeters, so we have 4 of those, so we have 1.6 millimeters, and then of course we have the width of the actual fiber itself is 0.9. The fiber often has to loop around and end where it started, okay, like this represents here. So in this particular case here, if we'll look at the extents in just a moment, here is a perfect example of a part with 2 walls, with the fiber looping back and ending where it started, and this I believe is almost 4 millimeters. Yeah, the extent here is 31.99 millimeters by 4 millimeters, so the width of a wall is roughly between 3 and 4 millimeters, and it may vary. Again, you need that overall cross-sectional area to sustain the minimum length of fiber, again, which is 40 millimeters. So I hope I answered that question with the minimum requirement. What other questions do we have, Ethan?
Let's see. Why is there a gap between the fiber starts and ends? In the visual there where you see the small gap between the tips of the fiber path?
Yeah, the algorithm generates that. Obviously, you wouldn't want them to overlay each other. It could actually potentially pull it up. That's something that our software engineers had designed. I actually don't know the correct answer to that. I apologize.
I think it just visually, that's the way the software will show it. That's the beginning and end of the fiber, so it looks like it's a gap, but
yeah,
really it's going right up to itself.
Yeah, that's actually a good question. I'll have to find out the answer to that. I apologize. Any other questions?
Just what's the best way to, when you're embedding parts, make it adhere to the inside of the...
Oh, yeah, that's a great question. Often what you can do is you can glue them in. I mean, you can use a CA, cyanoacrylate, or crazy glue, and that's what we recommend. Obviously, you don't want the insert to exceed the layer height of the cavity that you created. Otherwise, there's the risk of the nozzle colliding with it and causing a dislocation error. So you want it to be recessed just a little bit so that there's no... so it doesn't conflict with the motion of the print head and the actual nozzle tips. But gluing it in with a CA is what we recommend. It holds it in place, it bonds quickly, and as it prints, you don't run into any problems. Any other questions?
Let's see. Do you have any other features about the Mark II specifically versus the Mark I, or anything that we have a chance to talk about at all?
Yeah, the features, again, this is an Eiger demonstration, but I'd be more than glad to talk about that. Yeah, the Mark II is a great printer. One of the things that we've done is we've made some improvements on the inner hardware. The first major improvement, as mentioned earlier, with the Mark I, the minimum fiber length that had to be used was 610 millimeters. So 610 millimeters is rather long. You needed a cross-sectional area, again, to sustain that minimum requirement of roughly 1 square inch. Okay. What we did is we moved the cutter from the left-hand side of the chassis. If you open the lid, it was on the left. We actually moved the cutter to the head. We improved the fiber extruder. We improved the print head. We improved the nozzles. Overall, it is a super printer. In fact, the Mark I that I had at home is being upgraded right now to a Mark II, and I look forward to getting it back. I eagerly look forward to it. And again, the Mark II allows for the minimum fiber length to be 40 millimeters. I can't stress it enough. You're able to now add fiber to much smaller parts and much smaller geometries, and it is. It's absolutely beautiful with the design engineers and the software engineers. It's amazing what they've been able to accomplish on this second iteration of an already great printer. The Mark I's still a great printer, but there are limitations. Any other questions?
That's good.
Okay, what I want to do now is I just want to go over to the Markforged. Now, if you've seen the Eiger and you like it, there is a free trial. But before we go to the free trial, one of the things I want to show is that you can actually order these... this manual brake lever, and for some reason on my window, I don't know why I can't show it. You can kind of see it here, but you can buy a sample of this part, and what I'm going to do is open this in a window, and for $20 you can get both a if it comes up, you can get both a nylon version of it and you can get the full carbon version. This carbon version is exactly, the carbon layout is exactly what I did in this presentation. It shows how you can insert metal pieces, and of course it also shows how threaded inserts were pressed into it. For $20 you can have these. Highly recommend getting it. It's a great representation of what the Mark II printer can do. Okay. Now, with that said, if you're interested in Eiger, you can simply come to the Markforged website. You can select the Mark II and scroll down, and in the software section, there's a try it out. Okay, and this is the area where you can simply add some information: your name, your email address, your phone number, your company name, username. You create a username and a password, and then you just sign up. And after that, it'll come in, and if it's North America, Ethan will take charge of those, and he will reach out to you and then grant you a 7-day trial period. Extensions can be made, and of course, if it's outside of the U.S., Dan Berger, who's part of the sales and business development team, is also available to help with the Eiger trials. And extend them if need be. Now, one of the things worth mentioning is we do have, what I've been showing you is the Eiger, the cloud-enabled version, okay? All of the parts have been stored in the cloud, okay? This comes with all of the versions of the Mark II that we support. We have the standard version, the professional version, we have the enterprise version. If you were to purchase a professional version or the enterprise version, you do have access to the desktop version. We call it an offline version. And what that allows you to do, we're very sensitive to the folks in the defense and aerospace industry that they're very nervous about putting their parts up in the cloud, so they want to be able to store those parts remotely on their desktop. So having the desktop version allows for that. Now, in both cases, whether it's the desktop version or the cloud-enabled version, both versions do require internet access in order to use the software. The only difference is you're able to save the files remotely. So keep that in mind if you're looking at pursuing a particular printer. And again, that particular version of Eiger is only offered on the professional and the enterprise version. Great questions. Any other questions?
Nope.
We'll give it a few minutes, give it a few seconds just in case someone's typing. And while we're waiting, I want to thank everyone for joining in today. I hope you found this informative. Again, the Eiger software is very easy to use. It's very intuitive. Our software team has done a fabulous job. They're always constantly updating it. It's having worked at 2 3D printer companies before Markforged, I can attest that this is the best software that I've ever worked with. And I think you'll agree when you participate in the trial version and get some hands-on experience yourself. Okay, we'll give it just a few more seconds, and then we'll conclude the webcast. Again, this webcast is being recorded. We will post this online for any of your colleagues or folks who weren't able to join us today. And I think we're all set. I want to thank you again. I want to thank Ethan for joining in, and I want to thank Nick Sunday. He's one of our mechanical engineers. He was the one who designed that manual brake lever, and it's a great part and a testament to the type of parts, strong functional parts, that you can create on the Mark II printer. So thank you for joining us today.